All right, welcome. We're going to be talking about section R.5 in this segment. R.5 is the rational expressions. Anytime you see the word rational in a math class, it means fractions. We're going to be talking about fractions, algebraic fractions. I think R.5 is one of our hardest sections, probably one of the hardest sections in algebra to get our mind around. It's real tedious steps, so don't feel like this is like low-level review or be hard on yourself, because I find that advanced students kind of still struggle with rational expressions at times. So I'll do my best to give you the basics of it, and then you practice on it and let me know if you have questions. All right, so algebraic fractions. The first thing we're going to do in example 1, we're going to talk about domain. What does domain mean? In math, and we'll talk about domain later, domain and range later when we talk about graphing again, but just it's mentioned here, so I'll go ahead and address. Domain means what can you plug in for x? What is allowable to plug into the equation that will give you a real answer when worked out? So it just so happens in math, if you plug in a 0 in the denominator, it's just undefined. If you try dividing by 0 on your calculator, you'll find that you'll get an error message because there's just no reasonable answer for that. It's just not defined in math. So we can never have a 0 value in the denominator of a fraction. So when we look at this algebraic fraction, this first example, we have, and it's already in factored form. Sometimes they are and sometimes not. But here we see it in factored form. We're only concerned about the denominator equaling 0. You can have a 0 numerator in math. 0 divided by any number other than 0 is a 0. 0 divided by 5, 0. 0 divided by 7, 0. So the 0 can be in the numerator, just not the denominator. So there's two values you cannot plug in here that would cause this to be a 0. If we had x equals -2 here, we'd have 0 times something, so that would be 0. Or if we had x equals -4, because -4 plus 4 would make that part 0, and then these are times. So if either one of these parentheses had a value that made it equal 0, it would cause the whole denominator to be 0. So there's two values, and those are excluded. And so the way we say that, instead of equals, x cannot, draw a line for it, cannot equal -2, and x cannot equal -4. Everything else would be okay to plug in for x, but just not those two. All right, the next principle we see listed in our book is this idea of reducing fractions. We could have reduced that fraction. I probably should have done that before I erased it. But anyway, we're going to do that next up. So the principle, if you have an a times c over a b times c, again, this needs to be multiplication. In multiplication, we can cancel out common factors. So you could cancel out the c and reduce it to an, oh, sorry, that should be an a over b. Sorry, guys. So you can cancel out common factors when you're multiplying with fractions. So, but still, back to what I said earlier, the denominator values cannot equal 0. B cannot be 0, C cannot be 0. Cannot have a value that would make a 0 denominator. But otherwise, you just reduce away any common factors. So we're going to look at some examples that are reducible. So on example 2, in the form it's in right now, we cannot reduce it because it's not in multiplied factored form. We can't cancel out like 4 and 20 if that would be a thought. What we can do is try to factor. It's going to be all about the factoring that we learned in the last section. So if you can get these in factored form and then have a common factor, then you can cancel out. So again, you have to factor first. So in the denominator, the first principle of factoring is factoring out the GCF. What's common here is a 5 and an x can be pulled out of both of those terms, leaving 5x times x and 5x times 4. You can redistribute. Notice it is equivalent, so that is now factored. The numerator is one of those puzzles we talked about, the trinomials, that you have to do the reverse of the FOIL method. So I like trial and error, but we talked about other methods in our previous videos that you can use to try to get this to work out. But I know to get 2x squared, the first times first needs to multiply to be that. And then my next thought is the last times last to be -4. You never really think about the middle term. It just sort of happens when you get the right combo. If I use a +1 and a -4, I think that's almost right. But let's see, you get a 1x for your inner, and a minus 8x for your outer, which would be combined to be a negative 7x. I needed a positive, so it looks like I need to switch my signs around. Then if you FOIL this back together, you can confirm it does work. So you factor. Now it is acceptable to cancel out because this is all times. It's in factored form, and this is a quantity times a quantity. There's just not loose plus or minus terms. Everything's in multiplied factored form. Then if you have a common match, you can cancel out. All right, and then your answer is what's left. But we should note that we could not have used any values for x that would have made the original problem have a 0 denominator. So like here, -4. X could not have equaled -4, or x could not be 0. Those would be excluded from the domain if they ask you that. But if it just says reduce this fraction, that is the answer. All right, let's try that again. And as always, feel free to pause the video as needed to review that before moving on. Okay, B part, again, factoring is needed. In this numerator, there's a common factor of 3. We can bring out of each of those. In the denominator, this is the difference of squares we talked about earlier. We can factor it into the sum and difference of its roots. And again, you can FOIL that and see that it's so. This is not really an exact match, but they're opposites of each other by -1. If we were to times this by -1, it'd make a -x and a +2, which that's a +2 negative x. Then it would be the same. So they differ by a -1. Anytime you have exact opposites, they're just turned around at opposite signs. You can cancel them out, but it will leave a negative sign someplace, either in the top, the bottom, or the outside. But a -1 is left over from that. So I'm just going to put it on the top. It would be okay to place it, though, like I said, on the outside of it or in the denominator would all be equivalent. All right, next example. Example 3. Now we're adding in a second fraction. We're going to multiply fractions. Now with multiplication of fractions, not only can you cancel vertically matching factors, but you can cancel on the diagonal, anything that matches diagonally. So nothing needs to be factored here. These are actually all monomials. That's a times between that, so there is nothing that's a problem for us like on the last example. So we just start canceling right out. 9 goes into 9 once, and 9 goes into 27 3 times. This direction, 2 and 8 would reduce to a 1 and 4, and then y to the second goes into y to the fifth. 2 sets of those would cancel out, leaving y to the third. You might remember from a previous video when we divide, and that's what we're doing, we're canceling out factors, we're dividing out what's common. You subtract the exponents. So y2 and y5, you'd cancel out 2 sets of those y's. So what's left, we multiply across the top, we multiply across the bottom, and then that is our final reduced fraction. All right, we're going to just keep working examples of these to show you different ways this could look. These problems even take a while just to even write down, so there's a lot going on here. Okay, on this example, we need to do some factoring. Both of these look like the trinomials that we can redo the reverse of the FOIL method. So I'll be able to try to figure out what works for this. I'm going to guess 3m times 1m to get 3m squared. For my last times last, I need to multiply to get -8. I'm going to try -4 times +2. When I FOIL that, the inner is -4, and the outer is +6. That would add to be a 2, a +2. So again, my sign, I seem to get that sign wrong most of the time and then have to switch these. But then always recheck. That does work. The denominator also needs factored. 3m times 1m. I need to get +8, and everything's positive on this one. So I'm going to do 4 times 2 and kind of see ahead on that one what I needed. Sometimes I can, sometimes I can't. But that, check it out, FOILs to be this. Over here in the the fraction we have here, this is in its simplest prime form, and so is this one. Those sets cannot be factored any further, but it just so happens that this and that, they match. So that's a matching set. I can cancel diagonally. And then also the 3m plus 4s will cancel on that diagonal. And then here vertically, those do not match. They're not matching sets. So that will be my answer. What's left in the numerator, what's left in the denominator. And that does not reduce any further. Again, it has to be in times factored form, no loose plus or minus signs. On these, either they all have to go or nothing. It has to be a matching set to reduce it. So that would be our simplest form. All right, continuing on with that. Actually, the next one is division. I was going to say we probably need to divide next. Move on to the next step of this is what if it says division? And C part just so happens to do that. So another set of fractions. Notice it says divide this time. So I wrote that down, and I'm just going to have to write it again, because what we do in division of fractions is we multiply by the reciprocal. So I'm going to repeat this first fraction, and then I'm going to change this to times, and I'm going to flip the second fraction. Alright, and then repeat what we just did a minute ago. So yet another example where we have to factor, then cancel out any matching sets. So, puzzles. I'm going to get this out of my way. The original problem was divide, and now I've rewritten it as times. Everything needs to be factored. 3p times 1p is 3p squared. Then I need a negative 4 on the end, so I know the signs have to be different. I'm going to guess 1 and 4. Again, when I FOIL this, I'm hoping to get 11. There's a 1p in the inner. The outer multiplies to be a negative 12. Negative 12 and positive 1 is negative 11. So again, I'm missing that sign. Seems like I guess wrong every time, but then I can fix that. I don't worry about that because I know I can always fix that easily. In the denominator, first step is always GCF. If you have a common factor, we should always pull that out of our terms first. So what's common to 24 and 8 is 8 will go into both of those. And then P3 and P2. So the P's are common. You take the smaller amount will be the common amount. So that's why I brought out a P squared. That's what's common to both of these that could be divided out of them evenly. And then I say this times what? Times 3 to get 24. And P squared times P1 makes P3. So we're distributing here. 8p squared times what is this? I need a negative 1. All right, so that's just all I can do to that. Over here, again, I see a GCF. There's a common p, and then 24 and 36 makes me think of 12 will go into both of those. So I'm going to factor out 12p to the third, like so. That's all I can do there. In this denominator, there's a common 9. So factoring out the GCF a lot on those. And then we just cancel away anything that's vertical, or diagonal can be canceled, any matching sets. So I see a p plus 4 that's diagonal. Let's see, 3p minus 1 that's vertical. And then there's a lot of other things going on here. I see a p squared and a p to the third, so I can cancel out 2 sets of p's, leaves p to the first. I see an 8 and a 12, which will reduce a little. 4 goes into both of those. 4 into 8 is 2, 4 into 12 is 3. And then one more thing, the 3 and the 9 that's still there will also reduce. So you just reduce till you can reduce no more, and then multiply what's left. Across the top, I have a 1p, or just p, times the 2p minus 3. And in the bottom, what's left is just this 3. Oh, wait a minute, there's a 2, sorry. 2 times 3, excuse me, is a 6. And so you just multiply what's left. I see it didn't show up in your screen. So here is your final answer for your notes. All right, so that will do for reducing a fraction, multiplying, and dividing a fraction. In the next video, we're going to move to addition of fractions.